All right, everyone, thank you for attending. And thanks to Pivotal for inviting me here. It's really encouraging to see so many interested in domain-driven design. Of course, this is the way that I think software should be developed. And it's been a bit of an uphill climb from Eric's original publication of domain-driven design, tackling software or complexity in the heart of software. And we've come a long way since. Now there are actually conferences on domain-driven design and a lot of people interested, and I see interest in the United States now, and I don't mean just a little bit, but it's growing. And business people are getting involved in domain-driven design, which is really key. We're going to be talking about that today. So, reactive DDD, modeling uncertainty. Reactive, of course, is a big thing these days. It's really, gaining a lot of traction, and we're going to talk about why that has happened. But I think what's really interesting is that the way DDD was used or implemented, let's say back in 2003 or something like that, around those years, is quite a bit different than the way that we tend to use domain-driven design today. If you've read my red book, Implementing Domain-Driven Design, you're probably familiar with the fact that the bounded contexts that I model in the book are separate processes, separate deployments, whereas, I kind of get the feeling in reading Eric's blue book that at least at times, bounded contexts were separated logically, but perhaps deployed in the same deployment unit, perhaps in a web server or even an application server at the time. So we're going to talk about what the current use of DDD entails and the things that it means to our modern day use of DDD. But one thing to keep clear in mind is that the essence of domain-driven design is really still what it always was. It's modeling a ubiquitous language in a bounded context. So what is a bounded context? Well, it's, basically the idea behind bounded context is to put a clear delineation between one model and another model. And this delineation or this boundary that's put around a domain model makes the model that is inside the boundary very explicit with very clear meaning as to the concepts, the elements of the model, and the way that the team, including domain experts, think about the model. So you'll find a ubiquitous language that is spoken by the team, that is modeled in software by the team. And when I say spoken, I mean in scenarios and in discussions where whenever somebody says, for example, product, they know in that context exactly what product means. Exactly what product means. Now, in another bounded context, product could have similarities to the product that one particular team has defined product to mean. It may even share identities for whatever reason across bounded contexts, but generally speaking, the product in another context has at least a slightly different meaning and possibly even a vastly different meaning. So we're making an effort with domain-driven design to recognize that there is no practical way to have what might be called a canonical enterprise data model where every single element in the model is representative of how every team in the enterprise would want to use it. It just doesn't happen. There's always some difference, and many times there are many differences that make it very painful for one team to try to use and come to an agreement with the software or model that another team has created. So we're focused on the bounded context with a ubiquitous language. Okay, so once you understand that there is one very definite definition, for example, product, in one team situation with one ubiquitous language, then you realize that there are other models. There are other teams developing other models, or perhaps even the same team that's responsible for this model could be responsible for other models, but this is what it represents then. You have a situation where I now have multiple bounded contexts because naturally we cannot define every meaning in a single enterprise or a single system for every single concept that we're going to use. And so what we use is another tool besides bounded context with the ubiquitous language, but now we have multiple contexts, multiple languages, and we have to collaborate between these, and we also need to integrate between them. And so in order to do that, we use a technique called context mapping, or we use the tool context map. So the lines that you see between the bounded contexts here are contextual mappings. So if you look at the top at that representation of a bounded context and then the one lower to the right, there is a mapping between these two, if you will, a translation. So if you think about the bounded context at the top, if it speaks a language and the one lower to the right speaks another language, what do you need to have between languages so that you can understand one model from the other? A translation. And typically we will try to translate between models to keep each model pure and clean between separate teams. That doesn't always work out, and so there are context mapping tools for what is called a conformist relationship. There are context mapping tools for a partnership relationship where one team will know a lot about the model of another team. And then there's one called anti-corruption layer and customer supplier, which means that we'll tend to have very separate models, one upstream, one downstream, and we will anti-corrupt the upstream model as it's being consumed by the downstream, and if the downstream needs to send something back up to the upstream, it will translate it back to that upstream model so that data can be consistently and reliably exchanged with clear meaning. All right? So these tools haven't really changed a lot. Maybe there is, perhaps an additional context mapping tool that's been introduced along the way, but it doesn't seem to be used a lot. So these are the kinds of tools that we have to use with domain-driven design. And the strategic design part of it, what I have described so far, is really, again, the essence of and therefore the most important part of domain-driven design. Of course, we also, in some cases, will decide to model a particular ubiquitous language in a very careful, even fine-grained way. So if you think of strategic modeling or strategic design as being sort of the broad brush strokes with a large brush, then think of tactical design as using the fine brush to get the real details painted in. And that is tactical modeling with domain-driven design. Now, I've sat in on a few presentations today that, again, it's very encouraging to hear other people besides myself or others that are sort of known as the DDD leadership to be talking about DDD. That is exciting. But if you sat in on any of those presentations that may have mentioned domain models or domain-driven design to some degree, I'd just like to give you a little food for thought to maybe improve your chances of modeling in a better way. So don't take this as a criticism. It's just simply sort of like all of us working together as a team to try to make the DDD experience a better one. So of course I use Batman to express that, you know, zap. So it's not me doing the zapping, it's Batman, all right? So one thing that we have to remember about domain-driven design is when we are modeling tactically, especially, we need help from domain experts. It's not just me with the other programmers, right? It's we programmers on a team with at least one domain expert. Of course, we have to limit our use of their time because often domain experts, those who play that role on a given DDD team, will be very busy with other matters having to do with the business, and so we have to make that experience very rewarding for them, okay? Another thing that we want to do is avoid the anemic domain model. And you know, so whenever you see a presentation about a domain model, and maybe we throw in some annotations and say this will automatically generate the getters and setters and you know, equals hash code and toString, think seriously about running away from that. If our domain models were only about data, then this could be a very perfect solution. But how does the data come about? How do we actually get data into our domain model? Is it being expressed according to the mental model of the business and any domain expert that's working with us? Getters and setters do not give you an explicit indication of what the model means. It's only moving data around. And so rather than thinking in getters and setters, again, if you're trying to use tactical DDD, then you have to think that getters and setters are ultimately the enemy, because what you really want to model are behaviors that express the way that the business thinks about or considers this part of the business to work. So be explicit, and for example, maybe you saw the business identity of an entity or an aggregate being called a UUID. Well, there's nothing wrong with using a UUID as a business identifier, but why not wrap that in an ID type that is strongly typed? Because actually, how do you, for one thing, know what a UUID is in another bounded context that may not be using Java, right? So if another bounded context is implemented with whatever other language, you're not going to have a Java UUID compatibility across, and so probably what you're actually going to want to do is generate this random UUID to string, and then hold that string in another type, or at least translate that string from the type when you're sending out, for example, events across bounded contexts. Another one to look at too is, instead of using big decimal directly, why not think about a value object called money? Why? Well, one big thing is, if you've used big decimal before, you know that one of the most difficult parts of big decimal is identifying what's the rounding factor. So if we let big decimal slip in all over our model, or even into our application services or wherever, you know, how do we round? What are the rules just for rounding some amount of money? Well, use a money that standardizes on the rounding specification according to what the business says it should be. So just some little, you know, tips to kind of help with that. One other one might be, you know, to not worry so much about what persistence mechanism we're using or what messaging mechanism we're using. Use what meets your specific service level agreements, and And remember, unless you really are Google, Netflix, or Amazon, you are not Google, Netflix, or Amazon. So, just be reasonable about the throughput and so forth that you actually need, and don't complicate things. And yet, DDD is not really talking about technology so much as it is really in need of using technology, and so you have obviously some choices there. So just a few things maybe to keep in mind. So when you think about developing microservices of any kind, what view do you think a microservice gives you? In fact, if you were to think of microservices in this illustration, what is it? Is this looking at the Milky Way galaxy or another galaxy far away? Or are we actually looking at the atoms within cells or a cell? Or are we somewhere in between? So you have to think about the uncertainty that can occur at all kinds of levels in your software. You have to be ready to deal with that uncertainty. So if this is, the enterprise level, or even the entire internet, or if it represents just, the applications or systems in an enterprise, or if it represents the individual actors or asynchronous components in a single microservice, well, we have a lot of very interesting problems to solve with this. And what I am emphasizing in this presentation is not solving those with technology, as I was just saying, but model them. If we are developing microservices in the cloud as a means to perform business, then distributed computing is part of the business that we're working in. Not that distributed computing makes our business, in some cases it does, but we are definitely solving problems with distributed computing, so make the distributed computing aspects explicit. Model them, and I think that you'll see from what I show you in code in a while that this is going to be a very strong way, a very positive way of modeling uncertainty. Now, I also want to address something that some developers or anyone might use to argue against asynchrony, let's say, or concurrency or parallelism, whatever you want to call it. They're slightly different definitions, but they're all talking about at least producing the impression that a lot of things are happening at once, and in some cases, and literally today, many things are happening at once. And so Donald Knuth is often quoted as saying premature optimization is the root of evil, right? Of all evil. Okay. Well, I just kind of said that getters and setters are the root of all evil. So, well, what did Donald Knuth actually say, though? Do you know, have you ever actually really looked at what Donald Knuth said? This is only the end of his expression or sentence. Donald Knuth actually said, we should forget about small inefficiencies. Premature optimization is the root of all evil. But if we have these big, chunky, juicy, bottlenecks in our software, shouldn't we address those? And we can address those with reactive, okay? Donald Knuth said something else that I find very interesting. He said that people who are more than casually interested in computers should have at least some idea of what the underlying hardware is like. Otherwise, the programs they write will be pretty weird, right? Have you seen that I think it's a YouTube video or something where someone's writing software in Ruby or something like that, and it's mimicking, it's a presentation mimicking sort of or whatever the processors or the cores on a Intel processor by the number of breakdancers, right? Have you seen that one? There's one breakdancer in the center of 7 other guys, and they're all going, yeah, yeah, go for it, go for it. And there's one guy spinning until you get a blue screen, right? And that's what I'm talking about. Why don't we put the other 7 spinning on their heads too, right? So Donald Knuth is just simply saying, take advantage of the hardware that we have today by knowing your software. So if we go back some time to the year 1973 and look at sort of the way processors were performing at that time or were being manufactured, you know, there were very few transistors. The clock speed was below 1 megahertz. And so, you know, these processors were quite slow, but Moore's prediction or Moore's law said that we would see, you know, the doubling of processor speed and transistors about every few years. It ended up that the curve was even steeper than Moore's law stated, and yet when we reached 2003, so 30 years later, what happened? Oop, the clock speeds just started to fall off. And today, what used to take about a year and a half or 2 years at most to double clock speed, today is happening in about 10 years. If it even happens within 10 years. Transistors are continuing to increase, but the clock speeds aren't. So what do we do? And interestingly, why do I use the year 1973? Just because it's, you know, 30 years? Well, there's a point to that. So today, what we have are cores. And they're not much faster cores, but there are many more cores. So just in this Macintosh, you know, this MacBook Pro that I'm using here, I have 8 cores, right? So I can run, well, I have 4 cores with 8 total threads that can run because I have hyper-threading. So just on this little Mac, you know, I can do things that in 1973 were only greatly wished for. So what do we do now with all these cores? Well, and if you've been keeping up with Spring and the Reactor project, we can, you know, which uses reactive streams. This is essentially what we're able to do now. We have a publisher, and a publisher is publishing something, let's call them domain events. Those orange things are messages that are domain events, and they're being published to a stream, and then they're being delivered to each of the subscribers to that stream. But notice that there are sort of these lilac boxes there on the stream that have question mark on them. That is actually a policy, and that policy is a policy between the stream and the subscriber, right? And the subscriber says, this is how many events, for example, or messages that I can handle at any given point in time. And so that policy states what any given subscriber is able to handle. Maybe some subscribers are slower or faster or whatever, but the point is, a separate thread is being used to run the publisher, the stream, and all 3 of the subscribers. And if this is an intelligently implemented large, you know, complex component, the threads are not being blocked at any time. This is important, because if we're blocking threads at any point in time, it means that some other piece of the puzzle, like another subscriber or maybe the stream or the publisher or something, is starving for a thread at any given time. So we have to make certain that the implementation underneath is also making very good use of threads. So think about this now as we go into, you know, a deeper dive into modeling uncertainty, all right? And why it's necessary. And I'll just make a note that, as you know, I'm or you may know, I'm really, on the reactive side of things, very interested in the actor model, and maybe we'll have a chance to talk about that a little bit later. But ultimately, what we want to produce, and now make your mind go back to that powers of 10 illustration, right? So within a microservice, we have reactive, right? So that microservice itself might be viewed as one power of 10 scale, but then when we look inside, there are all kinds of components that could be running concurrently or in parallel. And now, when an event is published by inside one of those microservices, it's ultimately being published outside the bounded context to some sort of topic. You can think of that topic as Kafka, if you'd like. And maybe there are all kinds of topics, but let's just say we have one topic to keep this conversation simple for now. And all of the other microservices in our system solution, right, the reactive system solution, are reacting. They're ingesting or consuming those events that have been published on the topic, and then they are reactively doing things inside their microservice based on the facts. So you see how we're, in essence, zooming in and out in powers of 10, and now if we zoomed back even further, another power of 10 or 2, we might see an enterprise or a section of data centers and the cloud or whatever it happens to be. Okay, so ultimately this is where we want to be. And when everything is happening asynchronously everywhere, right, what happens? Well, let me just say that this is what we'd like to have happen, right? So I want to take event 1, event 2, and event 3, and I want to put them into some sort of a store, and I want them to be in exact order. And then when I read them out of that store in some way and I publish them to the outside world, I want them to be consumed in exactly the same order and exactly one of each of them to every single consumer. Why? Because that's what we've been taught since we've been programming. If you've been programming more than 10 years or even a few years, you know that we have been taught to jealously guard this scenario. We want that to take place because it makes us feel certain about what we're doing. And yet, in distributed computing, it just doesn't happen. So let someone tell you that they have once and exactly once, delivery of messages. Well, okay. I think some have probably appropriately named that claim as effectively once delivery, okay? Because in reality, it's just not going to happen this way every single time. Even if your system can guarantee exact ordering and no duplicates of any of these events, there will be one time, somewhere in time, where that won't be true. And so you have to model for it. And if you don't, well, okay, go read the postmortems about, these serious system crashes because you didn't plan for that to happen. All right? Okay, so by the way, what does uncertainty mean? I found a really great definition of uncertainty. Maybe you'd like it too. Uncertainty, it's pretty succinct, right? One thing that I learned from this is that uncertainty is a state. Bet you didn't see that coming. Uncertainty being a state means that we can deal with it. We have ways of reasoning about the state of a system, whether the state of a system or the state of a component or the state of some small unit of state in the whole system, whether it is what we would consider right now to be consistent or whether it's inconsistent at any point in time. And ultimately, we want to get into the point of that we consider that state to be certain, to be finished, to be completed. Think of all the words that you want to wrap around that to make you feel comfortable. And yet, you know what? It might be certain for that long, right? A millisecond or less. And then what? Uncertainty, where are we here? Uncertainty creeps up and it makes things unpredictable, unreliable, risky. Think of all these words. What it actually means is uncertainty is uncomfortable, okay? It's just a situation that we don't like to be in, and so how do we deal with it? And I want to illustrate uncertainty in a certain way. How many of you here have spent any time in a desert? Desert? Oh, cool. Yeah, a few desert people. I live in the desert now. I used to live in Colorado for a long time, but I now live around the Phoenix, Arizona area. And you ever seen one of those? That's a big scorpion. That's a really big scorpion. But I have friends who have lived in Arizona for a long time. And I'll tell you, that scorpion is was about the length of my fingers, my longest finger. I've been told that there are scorpions twice that size. And my wife stepped on one of these about a year ago in the dark. I mean, it hurt. It hurts badly. So think about, those moments when you feel comfortable, most of your life, right? You felt comfortable getting up in the dark to go where? Well, where you need to go in the middle of the night. But now, have this in mind. When I put my feet on the floor, am I going to get stung by one of these? When I walk that familiar path, to where I really need to go right now, is there a chance that I'm going to get stung by one of these? Okay, so you keep a pair of, house slippers or bed shoes of some kind by your bed, but what if one of those has crawled into your, I mean, there's just a lot of uncertainty. So, one way of dealing with it is, you can get your home sprayed several times during the spring and summer. Another way to deal with this is you keep a blue light, actually, like a little flashlight with a blue light on it next to your bed, and before you slip your shoes on, you point that blue light in there, and if there is a scorpion there, it will glow in the dark for you. So that's one way to get around that. So we do have ways of dealing with uncertainty in uncomfortable situations, but we have to remember to use them, and we have to think it through, and we have to take the right initiative and guards. So let's talk for a minute just about the addictions that we have. How many of you learned that this was the right way to develop software? I have a client. I don't mean a client like a remote client. I just mean a client object, let's say, and a server object. And the client object is going to invoke a method, right? Call a function, whatever you want to say, on this server. And while that happens, while that invocation occurs, the client is just sitting there going, "Whew, I feel so good. I'm so certain that I'll either get a response or that server or something below it will throw an exception, and I'll just be able to, wait around until that happens. And then I'll get control again, and I just feel certain about that, okay? So that's one addiction that we have. I mentioned this other addiction, total ordering, no duplicates, right? Oh, we love that. Here's another addiction, right? The locking database. Okay, I have n nodes in my data source, and when I write to one of those nodes, I'm going to have a firm lock so that I know that when that value hits that disk, it doesn't matter what order they hit in, but when I get back an OK response or a success response. What do we feel about this situation? It's on all 3 disks. Okay, we're good. And then you try to start using Cassandra, right? You just can't count on that. In fact, how do you query for a value that hasn't propagated across the cluster yet? So all of these things are creating an uncomfortable feeling in us, and we have to learn to deal with that. And yet, it's okay to feel uncomfortable. Here's another thing to consider. Perception. This is an autostereogram. How many here see the cleverly hidden object in the autostereogram? Do you see it? Sometimes people see it right away. Shout it out if you think you got it. It's a shark. Exactly. But we can train ourselves to see it, but it's not readily viewable. For me, actually, I don't know if I got LASIK 10 years ago or something, and now I have one eye that sees further and one eye that sees closer, and I used to be able to see these easier. Now I don't. But if you sort of squint, just try this, squint a little bit, and sort of make one of your eyes cross, or both of them, and stare at it for a second, you might see a shark. Okay? And I promise it won't be like your mom said that your eyes will get stuck like that. They don't get stuck. Okay. What do I mean by this? Okay, perception is all over the place in distributed computing. In fact, cleverly hidden inside this Intel processor are other cores, right? And so we have to learn to squint to see those. We have to learn to squint to see the fact that we can use all those at once, but yet the uncertainty is not too much to deal with. Now here is typically, because we're addicted to certainty and blocking and synchronization and all this stuff, this is sort of what we tend to do as developers. We build Fortress. So we've got this microservice, right? Bounded context or not, doesn't matter. You're putting some kind of a circle around this microservice, and you're going to make sure that everything on the inside is synchronized, not duplicate, blocking and whatever. And so what do? This is our fortress. We go at the infrastructure layer, let's say, and we create a de-duplicator and a resequencer. You know those patterns from enterprise integration patterns, woo, right? I even have some of those in my second book, or both of those. You can use them like this. You've got a de-duplicator. I have event 1, 2, 1, and 3 on its way in, and when I get past the de-duplicator, I'm certain that I only have event 1, 2, and 3. That's kind of easy to solve that problem. Not too difficult, but what does it mean actually? Think about the implementation of this. Okay? So we've got a data source somewhere, and we're saving these. You can cache some of it in memory, but you're not going to cache like a week's worth of events. Most likely, even though we aren't Google, you're probably still not going to be able to do that long term. And so what we do is we create some database table, and we say, okay, the ID of this event or the sequence of this event, we've seen that before. And so when any event comes in, we now ask the database, have I seen that before? Nope, okay, I'm going to let it go, right? We have seen it before? Okay, I'm going to ignore it. Seriously? Can you ignore it? Why have you seen it once before? Is it because you didn't acknowledge that you received it and you're receiving it again? Should we acknowledge it? How long do we keep those IDs around saying that I've seen that event? Is a week enough? How about a month? Talk about uncertainty, right? Trying to solve these things by throwing technology at it can be very difficult. Take a resequencer, right? We see event 3, event 1, event 4, and then for whatever reason, event 2 just kind of hangs out there for a long time. These are already in order, but we find a way to reorder them, right? And then event 1 becomes the first event. Event 2, eventually we'll get there, but let's say for now, events 3 and 4 arrive, we resequence them. Event 2 doesn't arrive. What have we just done to our system? We've just effectively shut down part of our system. We've said, we're not going to let event 1, maybe we will let event 1 go, but we may have some causality that says, don't even let event 1 go until we see event 2, maybe. And so we actually wait to see event 2 after some time, and finally we say, okay, let's let all of this go into the application. You know what? All of these things are hard. There's uncertainty, and you know what the biggest problem is? We haven't solved anything for the business yet, right? We're just solving technology problems. But if we acknowledge that distributed computing is part of our business now, then we can solve these problems in the model. So think about this. You know, this is what we want to say. Stop everything. Okay, I'm ready now, right? That's what we're saying. And yet there is no now. There's no now. If you think that your business model is consistent, it may be consistent for a nanosecond and then inconsistent again. In fact, you know what? I say that there is an insidious bug all around the Java world. It's just not true, right? It's just not true. I mean, as soon as you call into it, it's no longer now, right? When you get it back, it's no longer now. So uncertainty in a distributed system, you know, it's here to stay. I don't know why people got such a big kick out of this, but they keep getting a big kick out of it. And I just say, if you don't like distributed computing, change careers, maybe open a restaurant. But you know what that'll mean? You'll still be using distributed systems even though you're not writing them anymore. And one guy followed up saying, you know what, I'd rather take my chances with computers. Restaurants are really uncertain. So uncertainty, modeling uncertainty matters. It matters because cores are here, because the cloud matters. You know, it's here to stay, evidently, right? Time sharing all over again. Microservices matter. It's just the way that everybody is going. Most people are these days approaching me about domain-driven design because they see it as a great way to implement microservices, and I agree with that. But ultimately, you know, people want out of the monolith. Companies want out of the monolith. They are stuck. They're in the mud. It takes them months, if not even, you know, more than 6 months to get a release out of any given service or part of the system because they are just stuck. Okay, so microservices matter. Latency matters. When you have a network in there, even if it's Google's most awesome network in the world, you're going to have some latency. IoT matters. You know, the network is obviously involved, but maybe a lot of uncertainty around these little devices that are talking through the network. And they're all cheap, so we can afford to do this now. People are giving money, they're funding this, right? They're funding all this, and therefore we have to be able to do it. You know, look back 10 years ago, there wasn't much funding for stuff like this. Okay, so I want to just make a statement in general about DDD and modeling, okay? And what I refer to as good design, bad design, and effective design. So, do you know that you can design software well, right? It can be a good design, and yet you can completely miss what the business needs. So, take Solid, for example. This is in no way, shape, or form railing against Solid. Solid has good stuff. There have been people speak out about it recently. I'm not doing that. I'm just saying that you can design 100 classes to be solid, and yet you can completely miss what the business wants. Alan Kay said that the really important thing between objects are the messages sent between them. So the objects themselves are like little computers, but the messages between them are the important thing. Alan Kay referred to that as Ma. I hope you know who Alan Kay is, right? The inventor of OO, small talk, and so forth, right? Ma. What does ma mean? It's a Japanese word that, I don't know Japanese, but I guess it's supposed to mean something like the space between. What is between, the negative space or something like that, between, in this case, the objects. So you not only want the objects there, and they need to be designed well enough to play the role, the single responsibility that they're supposed to play, and yet we don't want it just to be all about the inside of the object. It's really about the names of the objects and the messages that we send between them. That is where the expressiveness in the ubiquitous language comes in. And if you are able to capture that in your model, that is what makes your model effective, not just good, but effective, because you will be meeting the needs of the business. And that is what domain-driven design is about. And so we want to develop reactive systems. We're going to deal with the fact that uncertainty is a state, and we're going to start solving some problems now. So let's look at are you familiar with Pat Helland? So he worked at Amazon for a while. He published this paper called Life Beyond Distributed Transactions, and the subtitle of it is An Apostate's Viewpoint, because he was like a big global transactions proponent. He developed XA drivers and so forth for companies, and so he knew a lot about distributed computing and distributed transactions. But when he came to Amazon and he was asked to solve certain problems, he simply realized can't be done. Amazon will never scale to where it needs to scale if I keep saying that we need to use global transactions. Okay? So read this paper, but one interesting thing, actually there's an update. There's an older version that's like a PDF version, but there's another one on the web somewhere. I can't remember exactly. Maybe it's on the ACM or something. And but something that Pat Helland says in this updated version is, in a system that cannot count on distributed transactions, look at this, the management of uncertainty must be implemented in the business logic. Do you think that doesn't catch the eye of a DDD person? Right? In the business logic, okay? Now, Pat Helland in this paper talks about an activity. What is an activity? So, any two entities in Amazon's system are considered partners because they collaborate together in some way. Other two objects that don't collaborate in any way are not partners. So you have to collaborate to be a partner. And between any two entities, let's say in Amazon, there's uncertainty, but we're trying to track the uncertainty through what's called a partner activity. So we have this partner entity, something happens to it, it state transitions, and it sends an event or some kind of message about this is what happened, right? And then eventually this entity over here will see that message, or hopefully it will. Probably in Amazon it will most likely see it almost always, right? Okay, that's good, but when? When will it happen? What if we lose, some region in our cloud, right? What if just the messaging mechanism disappears, SQS, right, for Amazon? What if? So all these what ifs, and so Pat Helland says, control this by activities. So between any two partners, each partner has to manage the activity that it has seen from the other partner to itself. And so this is kind of how I interpret what Pat Helland meant by that. So I kind of see a Java class as partner activities. So we have one of these for every partner that we have, right? A partner activity. So this represents the activities of one entity that is somehow related to us, and we're receiving activities from it. And so we can model this as a hash set or something like that, and we can just say, okay, let's record the partner that had some activity directed toward us, and we're going to record that. And then at some future time, if I need to look back and see, did this partner activity occur, right, because I'm dependent on it, or I see it again, I can ask, have I seen this partner activity? Okay? Pretty clear, right? Pretty simple. But what do you think happens in a long-lived entity? And even Pat Helland says this can grow enormously, right? Any given long-lived entity with even a lot of partners, potentially, you can run into collecting these huge entities, or what DDD would call an aggregate, and just to try to track the activities. And besides, this is not really explicit in any way. It doesn't say a thing about the business itself. So I think that we should go further than a partner activity, and this is a technique that I'm proposing, is where should this be? It should be in the heart of the software, in the domain model, okay? So again, we've taken that infrastructural mechanism or a couple of mechanisms and thrown them out. We're just going to let everything through as it happens, right? And it's actually going to be less complex. So here's an explicit model where we have, if you look at the bottom two objects, we have a proposal and a job, okay? So the first thing that happens in this particular model is a client is going to propose a job that needs to be done, or a task, if you will, or a number of tasks. And eventually, we're going to allow that proposal to bubble up so that workers can take that proposal and accept it and then do the job that is desired. But until we understand exactly what this proposal is saying and the pricing that the client is willing to pay, we aren't going to allow that proposal to advance. It's simply submitted. Well, it can advance beyond submitted, but still not completed until, for example, its pricing is validated and its scheduling is validated. Okay, we don't want to say necessarily validated because it's really accepted or rejected. And even a rejection in pricing doesn't mean that that's the end of the road. We're simply going to suggest a better price, okay? So this is all part of this business model that is modeling a peer-to-peer business. So, somebody needs a little job done, somebody's willing to do it. It could be walking a dog, could be washing windows, it could be fixing a drain, in your kitchen sink. It's a lot of different things that are pointing here. So we have events and commands, and the blue things, the blue messages are commands, and they're flying around everywhere, right? But in essence, this is what's happening. We in our matching model, we have a proposal that has some kind of progress. And we emit some kind of event that pricing and scheduling and fulfillment and so forth will eventually see. This particular event that we're talking about right now is an event that is named, let's get to it here, proposal submitted. So when pricing sees that a proposal is submitted, it's going to do some calculations and it's ultimately going to say pricing denied or pricing approved, okay? And if pricing is denied, we're going to give a suggested price, so we're going to give the client another shot. Similarly with scheduling, but these are two different models, and we're translating the proposal submitted into something that pricing and scheduling individually those bounded contexts understand. Okay, so that's our model, or models, our 3 models that we're looking at. And another thing that you might want to think about is what's core here. You might think that the matching is core because this is where we make all our money, right? This is where a client and a worker get matched up to do a job. But when you think about it, that's just pretty much a simple web app. We've been writing those kinds of web apps for quite a long time. What's really interesting about this is that the P2P economy company is going to make its money actually through pricing and scheduling, because they're going to figure out, is this an after-hours job? Is it a weekend job? Is it a holiday job? And if so, then we're going to have to bump pricing, make other suggestions, and we're also going to evaluate the clients and the workers at the same time. So there's a lot of important things going on, but I would say that pricing is at least one of the main core domains in this P2P economy web application or web system. So how do we deduplicate, for example? Just deduplicate. Okay, we see an event come in, such as proposal submitted. We're going to translate that into a command that fits our model, right? So the event belongs to another model. We're going to translate that at the edge, at the infrastructure in essence, and say, okay, here's the command that may or may not be accepted, but it's what our model understands. And so we send that command to an entity, and actually all that we do is we keep the state on the entity that says, have we seen this before? But we state it, and I'll show you soon, we state it in terms of the business. We don't look at it as a partner activity. We look at it as a business modeled concept. Okay? So we're going to keep that state, and if and only if this state has never been seen before, we will emit another event, such as price accepted. And then if there's a non-commutative kind of event that comes in, then we're going to have to keep some identity, because it could be that if this is an addition, subtraction, multiplication, whatever kind of operation, we could put our state into a very invalid and very bad state if we were to perform that operation multiple times. So what we're doing is really just keeping some identity around for that. Order and sequence, what do we do if we receive multiple event 1 maybe, or event 1 and event 3, but we don't see event 2 for a while? You know what we do? We just let them through. And it doesn't matter, in essence, what sequence those arrive in. We simply know that it either has occurred or it hasn't occurred, and that the entire mini process that is implemented on this entity isn't completed until 2 shows up. So we have step 1 is X, step 3 is Y, and step 2 is going to be Z at some point in time. We don't know yet what that's going to be, or when it's going to happen, and yet it will likely happen. And once that entire state is considered completed, right, now we can move forward, allow the rest of the process to move forward. Similarly, we can calculate what's the closest, right? Who's closest to this task, or whatever. But the data that we collect on the where is it is different now than it was for deduplication or reordering. And we can even answer the question, given a multiple choice, which is, for example, the first or the fastest to be able to fulfill this role. We can solve all of these problems by simply letting the impact of the event to to go through. We react to that event, and eventually when we see all of the events through commands that have been translated, then we have our model. Sometimes this can turn into a bit more of a complex process, but there are ways of dealing with this through what's called a process manager. And even though you might think, woo, this looks really crazy, it's really pretty simple. You have, again, multiple partner entities on the left-hand side. They're emitting events, and those events are making their way to the process manager, and the process manager is just a state engine that's saying, okay, if I haven't seen this yet, I'm going to issue a command to some other partner entity to say, do this in response to the fact that this happened, so it's all reactive, right? And yet the process manager is really just a state machine. Ultimately, you may or may not finish this given process, but things just keep cycling through it. Okay, so let's go to some Java code. And let me see here. Okay, so I have two examples here. And how close is it to 5:30? How much time do I have? 9 minutes? Okay. So I have two examples. The first example that I want to show you is using event sourcing. So this is this, done by me proposal model. And this is an event sourcing model. So as you can see, we have a proposal. It extends this event sourced root entity, which is just an abstract base class that kind of gives us some help in dealing with an event sourced aggregate or entity. And the code that I have here is, one of my goals in modeling is to be as expressive as I can. So notice that even in this case, I don't have a public constructor. I have something that expresses the fact that a proposal is submitted, right? So it's submitted for a client with some expectations, right? So in essence, what does that do? It just uses the constructor. And it's this constructor, and so what we do is we just, we're going to call this constructor with a progress of none, right? So what we're saying is we made no progress right now, and progress is just, the progress.none is just an instance of a progress that hasn't made any progress yet. It's just expressive, right? So I'm not clouding my vision with new progress, or any, it's just, it reads correctly. It's this with a unique ID, a client, expectations, and no progress, right? So ultimately, this is where we're headed. We're going to this constructor, and what does this constructor do? All this constructor does is, okay, we now know that we have, some kind of valid expectations and progress, and so we're going to apply a domain event. Again, notice I'm not using the proposal submitted constructor, the event constructor, but I'm saying proposal submitted with an ID, client, and expectations. I don't need to record the progress because I know that when a proposal is first submitted, there is no progress. So I'm not recording that. It's simply a fact that a proposal has been submitted. Now, what happens when I apply this event? What happens is, in our abstract base class, I make a record of this very domain event that gets created right here. The proposal submitted event gets created, and I'm going to save that into a collection, a list, so that it's ordered in the order in which it occurred. And then what I have is, I have this when method. It could be called on or whatever. When is not significant. It's just saying that when a proposal submitted event is applied to me, I'm going to be informed of that in the same thread. This is just a callback, right? So I'm literally going into this apply method in my constructor, right? And before this apply returns, so we have certainty here, right? This when method is invoked with a proposal submitted event. And then I'm going to take the state from that proposal submitted event, and I'm going to apply it to my proposal state, right? So I have state on my proposal, and it's right here. I have an ID. So notice I have a type on this ID. I have a client, which actually underneath this is just a simple value with an identity. I don't want a bunch of information about the client, and it's not an entity in matching bounded context. It's an identity in some other user registration thing, right? Bounded context. And then I have some expectations and I have a progress. And I know that when I receive a proposal submitted being applied to myself, I'm going to set my ID from the proposal ID. I'm going to set the client from the client's ID. I'm going to set my expectations that have been, stringified basically into something that now is actually a richer value object part of the model. And then I know because the proposal was submitted, my progress is none, right? My progress is set to an instance of progress that has made no progress. By the way, what does progress look like? Okay, so none is just a new progress. And of course, new progress is a hidden constructor because I want to be sure that everybody starts with no progress. There's no other way to get a progress other than if it's none. And then we're going to transition forward. So what's one of the things that can happen? So what can happen is we can get, after our proposal submitted, right? And just to, okay, forget it, I'm not going to do that. So our proposal submitted is going to be seen by the pricing bounded context, pricing engine, and it's going to accept or reject, and it's going to suggest a price if it rejects. And so we're going to now, in our proposal, out of band with this creation, so think of this proposal as somehow getting persisted, and it's persisted because the proposal submitted event is put into an event store, and that event store now holds the stream of this specific proposal with this identity, and we can read that stream back and apply it, right, down here using this constructor, which is a technical only constructor, and we're going to replay that stream using our when methods. So we're going to bring we're going to reconstitute the proposal back into the state that it was in when this proposal submitted first happened, and then the client of the domain model is going to tell proposal.deny pricing. And it's going to say, by the way, here's a suggested price of what we would like to see, something around this range we would like to have our client propose with that suggested price, or something near that at least. And so what do we do now? We just apply a progress with denied pricing and a suggested price. So what is that? So what we have here is we just go into our simple progress, right? This is our progress model where we started with none, at none, and now we're going to ask, okay, here's our uncertainty. Is this ultimately a redelivered domain event that pricing was denied? Well, if so, let's just return an empty list of domain events. Nothing happened, right? Otherwise, we're going to return a new collection of domain events called progress completed unacceptably and pricing denied, right? So these two, we're now emitting actually two domain events. Progress is completed and pricing is denied. So we know that this proposal has been completed. And when we see this proposal this pricing denied event, right? We're going to update our expectations using that event, and we're going to update our progress to pricing denied, and then we can now save, the state is in the state that it should be as of pricing denied. We save those, or we append those events to the event store, and our state is now represented by this additional domain event. And therefore, when we reconstitute the proposal yet again, maybe now the client comes back and says, okay, I'm gonna increase my price because I'm gonna get nearer to the suggested price. So what we need to do is bring that proposal back into its current state, and we're going to transition from there, okay? So this is all giving us the opportunity to very, very simply, actually one thing I wanted to accomplish by this talk was to completely underwhelm you. I want you to see that this is so simple. And actually what you're doing is you're relating to the business because you have a proposal that is going through progress and it's transitioning, and you can just look at it and read it and reason about it rather than going into some technical data store and trying to figure out what have we seen and what haven't we seen yet. Just ask the proposal where it is, right? You know where it is. You know where it is because of its current state, and you know where it is because of the events that it's emitted. You have several different ways of looking at it. And now, okay, how do we get back to, what if one of these events just seems to never show up? What happens then? Well, let me see if I can get back here. Sort of hate this. Okay, anyway, I had a fancy image of a clock, but you've probably seen a clock before. So what I was just going to tell you is that this fancy image of a clock says, create a timeout. Your business process will simply time out at some point. Your business is going to indicate what that timeout should be, not you, right? It's not you and your programmer friends on the team that are going to say, hey, let's make it, 2 minutes timeout. No. You want the business to make decisions like that. So this is part of your modeling heuristics in including the business is you model with a domain expert. You build on what you know. What do you know? You know that you have a submitted proposal. So you have a proposal submitted event, and you know that something in the system has to react to that. You're looking for some kind of input. So we can now model other parts of the system, other bounded contexts, according to responding to those domain events. And now we're going to expect another domain event back. So we just keep building on the little base of knowledge that we have until we've, in essence, identified the transitions of the state that the system needs to go through. And if the business says, you know what, let the proposal be submitted and transition for up to 10 minutes before we time out. And then if we time out, we're just simply going to let the client know, okay, this didn't go through, we're going to retry later or resubmit it. Now it's up. You see how the further you go down the line of modeling this, the more involved the business has to be because the business is going to determine what the business process is for getting a client and a worker together to perform some job so that we can make money, so that the worker can make money, and so that the client gets the work done that they need to do. So you can't just make this up on your own. If you try to run it alone, you're going to you're going to cause a lot of problems for yourself because you're now going to be playing the part of the business, and we are software developers who should really be engaging with the business to learn what we need to know. So, I did have maybe 1 or 2 slides other than the fancy clock, but that's pretty much it. If how much more time do we have? I'm what? Oh, I'm 5 over. Yay. Okay, so I apologize for keeping you here, but thanks for attending and taking extra time. I'll be around for questions if you'd like.